So in section 6.2, we're going to talk about properties of parallelograms. So we're working with polygons, and a parallelogram is a specific kind of polygon. So the first thing is the definition. A parallelogram is a quadrilateral, that means 4 sides, with both pairs of opposite sides being parallel. So you are very familiar with parallelograms. They look like this. The opposite sides are parallel. A rectangle is a common parallelogram that happens to have right angles. Again, the opposite pair of sides has to be parallel. So if you are trying to do some writing, like in a proof or something, and you have this parallelogram, you can abbreviate it by just doing this little symbol and call it parallelogram ABCD. You don't have to write out the word parallelogram every single time. Okay, so that's the main definition. That's what we're going to start working. Got a bunch of theorems. We're going to go through them. First one is theorem 6.3. If a quadrilateral is a parallelogram, in other words, if it has the opposite sides that are parallel, then we also know that its opposite sides are congruent. So I'm going to do a quick proof of this. You don't have to be able to do this, but given parallelogram ABCD, we want to prove that AB is congruent to CD. AB is congruent to CD, and BC is congruent to DA. So here's my parallelogram. A, B, C, D. Since I'm told that it's a parallelogram, I do know that I've got sides that are parallel to each other. And I want to prove that AB and CD are congruent. That's our theorem. And that BC and AD are congruent. So the first thing I'm going to do is I'm going to draw a diagonal. Now, I'm going to separate these into some angles, 1, 2, 3, and 4. So if I take this diagonal as a transversal, and I look at parallel sides AB and CD, by alternate interior angles, I know that angle 1 is congruent with angle 4. If I do the same thing using parallel lines BC and AD, I can say that 3 is congruent to 2. And we know that AC by reflexive property is congruent to itself. So now I've shown that by angle, side, angle, triangle ABC is congruent to triangle, let's see, I did ACB, so I have to do CAD. Therefore, by corresponding parts of congruent angles, I can say that AB is congruent to CD and that BC is congruent to DA. So I didn't do a formal proof, but just showing you how that we know that opposite sides are congruent, and we have now proven this. I'll do some work later with how we're going to make use of that. Okay? Theorem 6.4. If a quadrilateral is a parallelogram, again, the assumption that the opposite sides are parallel, then its consecutive angles are supplementary. So if I have another parallelogram, and I know that these are parallel, every parallelogram looks the same, I can now say that if angle A, AB, I should go around the circle, not opposite, AB, C, D. If angle A is 36 degrees, by theorem 6.4, angle A plus angle B has to equal 180. So 36 plus angle B is 180. Subtract 36 from both sides, and I get 144. So I now know the measure of angle B as well. So that's what theorem 6.4 allows me to do. Now I'm just going through these, but at the end I'll give you a problem or two that you can use. Okay? Theorem 6.5. Again, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So again, if we have a parallelogram, and I know that this angle is 120, again, if it's a parallelogram, these sides are parallel, I can say that this angle is also 120 degrees. By the last theorem, I know that this angle, I should label this, Angle B is 120, angle D is 120. If angle B is 120 by theorem 6.4, the previous one, I know that this would be 60. Its opposite angle would also be 60 degrees. These two are congruent. Okay, so now I know all four angles, and if you add them all up, we do get the proper number of the angle measure for our four-sided parallelogram, which was n minus 2, right, times 180. So this is four sides. I'm going back to the last section, and I get 360 degrees, and if you add up angle A, B, C, and D, we do in fact get 360 degrees. So if I've given one angle of a parallelogram, I should be able to find all the other angle measures. Theorem 6.6, if a quadrilateral is a parallelogram, are you seeing a pattern here? Then its diagonals bisect each other. So this time, if I have a parallelogram, again, labeling the sides as being parallel, the opposite sides. If I draw diagonals, then they bisect each other, meaning A equals C, it's bisected by BD, and those two sides are equal as well, they are bisected by AC. Okay, one other theorem, 6.7, if three or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So if I have three parallel lines, I'm going to do three for the moment, and there is a transversal that they cut into equal segments, then any transversal that I draw will also have equal segments. Doesn't mean that these will equal these, but this is bisected and these are bisected. Okay? So let's try, go back. Let's see if I can get a blank slide here. Well, let me just use this one. Okay. So just using this as a blank slide. I thought I had a blank slide at the end. If I give you this parallelogram and mark it so that I know that these are parallel sides so that I can use my theorems, A, B, C, D. And if I tell you that angle B is 110 degrees, side AB is x plus 2, and side CD is 2x minus 3, can you solve for all four angles and solve for x? So I'll give you a minute to try that. Okay, so all the angles, if this is 110, then D has to be 110. These are supplemental, so C would be 70, and A would also be 70. The opposite sides have to be congruent, so x plus 2 has to equal 2x minus 3, which means that x equals 5. Okay, let's try one more. Let's say we have this parallelogram. I'll call it X, Y, Z. I guess I should start with W. And I'm going to draw two diagonals. And again, this is a parallelogram, so I should mark it as such. And if I tell you that this segment is Y plus 1, this segment is 2Y minus 2, this segment is 2X, and this one is X plus 8. I didn't draw that very straight. That should be bisecting. Can you find the values for X and Y? So pause for a moment, see if you can do that. Okay, since these are diagonals of a parallelogram, these two sides have to equal each other. So y plus 1 equals 2y minus 2, subtracting y and adding 2, and x plus 8 has to equal 2x. So x equals 8. So that's kind of the problems that you'll be asked to do using these theorems to find missing angles or side lengths or diagonal lengths. And that's it.